When you're responding to a security incident, there is undoubtedly going to be physical and digital evidence that you'll need to collect. You protect the integrity of that evidence you're collecting by creating a chain of custody. This means that you document every person who contacts that evidence in any way. And if there are any changes to this evidence, we now have documentation that tells us everyone who might have made that change. If you're working with digital evidence, we often use hashes to have some type of integrity check that we can use along every step of the way. If you're collecting physical evidence, you can keep it in some type of sealed bag. And as you can see here, you can write details about what you have found, and you have a chain of custody to determine exactly who came in contact with the contents of this bag. Digital evidence often uses digital signatures, so you can tie back any access to this data to an individual. You might also find yourself being the first response to one of these incidents. When that's the case, you should identify what the issue happens to be. You can do this by checking logs. You can have in-person information that you can gather from other folks, and there may be monitoring data that you can collect as well. If you've determined that an actual incident has occurred, then you can report this incident to the proper channels. Most organizations have a list of individuals who should be directly contacted each time there's an incident. This is an important step, especially if this incident is one that deals with your local law enforcement group. We need to make sure that we get those folks involved as quickly as possible. Your objective should be to collect any data that you have associated with this incident and protect that information for other people in the organization. When we're dealing with digital evidence, we don't usually pick a single file or single folder and copy that off to a USB drive. Almost always, we are taking a copy of the entire drive and collecting every bit and every byte from that storage device. This copy process commonly collects what we call a bit-for-bit or a byte-for-byte copy of that drive. That means we're not only collecting the information that we can see in the files and folders stored in the file system, we're also collecting information that might have been deleted from the drive. Many operating systems will delete the pointer to a file, but the actual data of the file is still stored on the storage drive. That information only becomes inaccessible if something is written over that section of the drive later on. That means if we perform a byte-to-byte copy of the drive, we really do have an exact duplicate of that drive stored in an image file. This allows us to perform extensive analysis of that data later on without changing anything on the original storage drive. This copy is often done with a third-party piece of equipment that you would connect to the physical drive itself. That copy device often includes a hardware write blocker, so you can plug this in and you know that that device is not going to be able to remove any data from that piece of evidence. If you don't have a physical imaging device, you could use software imaging tools. So you might boot this system with a USB drive and then use software on that USB drive to copy all of your information from the internal drive of that system to a separate storage device or separate image file. And of course, since we are collecting digital evidence, we can use hashes and digital signatures to ensure the integrity of this information as our investigation continues. Something you'll be doing with every incident is documenting everything that you did and all of the information that you collected as evidence. This is not only important for internal use, so you know exactly what occurred during that incident. This might also be involved in a criminal proceeding, so you might need to use this in a court of law. This documentation might include a summary of this event itself. This way you're able to document what occurred during that particular time frame while it's fresh in your mind. As you're acquiring data from a system, it's important to document exactly what you did to acquire that data, including a step-by-step of the process you use to be able to grab that image or grab that data. If your job is to analyze the data associated with this incident, then you'll need to document everything that you find associated with this data. This allows others to also analyze the data and compare it to your analysis to verify the information that you found is accurate. And based on all of the data that you've gathered, the analysis of the data itself, you should document what you feel are the conclusions based on the information and evidence that you've gathered. One of the challenges we have with computers is that there's a lot of different types of data inside of our computing systems. Some of this data sticks around for a very long time, whereas other types of data may be gone in an instant. If it's your responsibility to collect this data and evidence from a system, then you'll probably want to start with data types that would disappear quickly. For example, if you think about registers in a CPU, those registers might change thousands of times in a second. This makes it very difficult to collect data from CPU registers or a CPU cache. We refer to data that disappears quickly as more volatile. We refer to data that sticks around for longer periods of time as less volatile. For example, an ARP cache might stick around for 60 seconds or 5 minutes, but something like a network topology might rarely change. Therefore, we can say that an ARP cache has more volatility than a network topology. This chart contains just a sample of the different data types that you might find in a system. CPU registers are at the upper level of being the most volatile, and then we have router tables, process tables, kernel statistics, and memory information just under that level of volatility. We then can have temporary file systems, which tend to stick around a little bit longer, and then we have data that's stored on disk. Remote logging data and monitoring data tends to stick around longer than information we might store on a disk, and things like a physical configuration or the topology of your network itself might be something that rarely changes, putting it down at the lower levels of volatility. And if you're putting information on a backup tape, that information might stick around for years. That makes it one of the least volatile types of data that you might collect. You can probably think of other data types that are contained within your system, and you might want to consider where that would fit in this order of volatility.